Hello my student, welcome to our physics lesson today, that is Manifested e-learning platform. My name is Purity Anzelimo, your teacher of physics today. During our lesson today, we continue with the topic electromagnetic spectrum. That's our topic. And this should be the last topic, not the last topic, but the last subtopic in this topic, electromagnetic spectrum. So from the previous lessons, we have been able to know what we mean by an electromagnetic spectrum, and we say that an electromagnetic spectrum is simply refers to the electromagnetic waves arranged in order of their frequencies or wavelengths. And we were in a position to list down all those electromagnetic waves, the 7 of them, in order of their frequencies. So during our lesson today, we'll look at the hazards of some of the electromagnetic waves. We can talk of hazards or simply the dangers of electromagnetic waves or the EM waves. The hazards or the dangers of the electromagnetic waves. But before we look at these hazards, during the previous lesson, we were looking at how the electromagnetic waves are produced, how they are detected, and how they are used. And I remember we mentioned about one of the electromagnetic waves, that is the infrared radiation. And one of the uses of the infrared radiation, we think that it can be used to warm the greenhouses. It can be used in warming the greenhouse. And as I have said, we are going to explain first how does it work in a greenhouse, or what we call the greenhouse effect. So that's what first I'll explain. Then we'll finally look at the dangers of some of the electromagnetic waves. So we go back and look at this use of the infrared radiation, which we are saying that the infrared radiation can be used to warm greenhouses. So we briefly look at the greenhouse effect. And this is simply what we refer to as heat trap. The greenhouse effect, or simply what we call the heat trap. So we want to look at how heat is trapped in the greenhouse. That is the greenhouse effect. You can be told to explain how a greenhouse effect is all about. Now, when we talk of the heat trap in the greenhouse effect, we have visible light from the sun, which has low wavelength. So we have light from the sun of low wavelength. When it has low wavelength, of course, it has a high frequency. So light from the sun of low wavelength is able to penetrate the glass, the transparent glass. Light from the sun of low wavelength penetrates the transparent. It is able to penetrate the transparent glass that is now in the greenhouse. It's able to penetrate. That is one thing that you need to note, that light from the sun of low wavelength, of course high frequency, penetrates the transparent glass in the greenhouse. Now when it penetrates in the greenhouse, for example, we can have objects like maybe the plants. We usually have maybe flowers which are grown in a greenhouse. So we can have maybe like the plants. So when the light from the sun penetrates the glass in the greenhouse, it is absorbed. So it is absorbed by the objects in the greenhouse. So it is absorbed. Again, now we have it being absorbed by the objects in the greenhouse. So that's what happens. Light from the sun of low wavelength penetrates the glass, then it is absorbed by the objects that is in the greenhouse. And in return, we have now light of high wavelength or what we call now low frequency, because now when it is absorbed by the objects that are in the greenhouse, in return they will give light of a higher wavelength. So the objects will emit light of now high wavelength. They will emit some light but of a higher wavelength. Because in this, what we are saying is that this is wavelength, high wavelength. So when the objects in the greenhouse emit light of high wavelength, this light cannot be able to penetrate the glass again. So this light of high wavelength, the high wavelength cannot penetrate the glass. They cannot penetrate the glass. And this is because, when now it has high wavelength, it means that it is of low frequency. And when it is of low frequency, it means that it has low energy. And that is not the penetrating power. Penetrating power of the light or of any radiation is determined by its frequency. The more the frequency, the more the penetrating power. So when these objects in the greenhouse have absorbed the light from the sun, then they will emit light of high wavelength. And because this light is of high wavelength, meaning that it has low penetrating power, then it cannot, or that radiation, we can talk of the radiation instead of the light. So the radiation of high wavelength cannot be able to penetrate the glass. So the radiation of high wavelength cannot penetrate the glass. And what will happen when it is not able to penetrate the glass? Then it means that it will bring out what we are calling the heat trap. And therefore, heat will accumulate. Heat will accumulate in the greenhouse. In the greenhouse. And this is simply what we are referring to as the greenhouse effect. If I may explain it diagrammatically, this is what we mean. If this is our glass in the greenhouse, this is our greenhouse, and of course here we have some, let's say we have the plants here. These are the plants in the greenhouse. Now when we have light that is from the sun falling onto this transparent, this is our transparent glass, and these are the objects in the greenhouse. So what happens is that when we have now light from the sun falling to the objects, falling to these objects that we have here, can have another ray here. These are rays of light. So we have them falling on the objects here. And we have seen that this radiation is of low wavelength. Low wavelength, and therefore high frequency. And therefore they are able to penetrate the glass. And once they penetrate, we are saying that they will be absorbed. The radiation will be absorbed by these objects which are here. So when it is absorbed by the object, they will now in return emit radiation, but now of high wavelength. So they are going in return to emit, they are going to emit some radiations. So they emit the radiations. These are the emittent radiations. They will emit the radiations. This one can also emit the radiation. But now, these radiations are of high wavelength. They are of high wavelength, and because they are of high wavelength, then it means that they cannot be able to penetrate this glass because their penetrating power is low. Because when they have high wavelength, it means that they have low frequency, and therefore the energy that they possess is not as much as the ones that are incident on the transparent glass. And therefore, because these radiations cannot penetrate the glass, then it means that there will be accumulation of heat. And as a result, these objects which are here will receive a lot of warmth, or they will be heated. And this is what we call the greenhouse effect. And that is why when we have, for example, flowers which are grown in a greenhouse, we have them growing at a faster rate because of the heat that is trapped in that greenhouse as a result of what we have explained. So this is the heat trap, which we refer to as the greenhouse effect. And we have seen that it is one of the uses of one of the EM waves, which we call the infrared radiation. So this radiation that we are talking about is the infrared radiation, because we say that in the production of the infrared radiation, we say that one of the major sources of the infrared radiation is the sun. And therefore, just to repeat, light from the sun of low wavelength and high frequency penetrates the glass, and then it is absorbed by the objects in the greenhouse. Then the objects will emit light, or they will emit radiations. We can talk of radiations. They will emit radiations. They emit radiation of high wavelength. And the radiation of high wavelength cannot penetrate the glass. So heat will accumulate in the greenhouse, and this is what we call the greenhouse effect, or simply the heat trap. So that is it. That's basically how a greenhouse works. So now back to our lesson today, that is on the hazards or the dangers of the electromagnetic waves. Now we think that let's first start by, we can start by lighting the electromagnetic waves in order of their increasing frequency. We think that we have the radio waves, which have the lowest energy. We have the microwaves. We all have the infrared radiation. We said we have now the visible light. After the visible light, we have the UV radiation. Then we have the X-rays. And finally, we have the gamma rays. And we think that gamma rays have the highest energy. Because we think that energy is simply directly proportional to the frequency, so is equals to HF, where H is the Planck's constant. Now, when we have these electromagnetic waves, some of them are very dangerous, and long exposure to these electromagnetic waves, and especially the ones that have very high energy content, that is the gamma rays, the X-rays, the UV radiation. Long exposure to them can lead to the destruction of the cells. Also, it can also bring out what we refer to as skin burns, and it can also bring issues with the eye. So we can write those hazards on what we are calling the dangers of some of the electromagnetic waves. So we can say that the penetrating power, of the electromagnetic waves can cause damage. When not controlled. when not controlled. And this is what we are calling the long exposure. So we can say that long exposure, the electromagnetic waves like the UV radiation, the X-rays, and the gamma radiation can result to, so number one, it can result to what we are saying the skin or the skin burn. We can talk of the skin burn. It can also lead to the damage of cells, and it can also lead to effects or defects in the eye, can also cause problems to the eye problems. So that is on the long exposure to most of them, and especially the ones which have a lot of energy from the UV radiation, the X-rays and the gamma rays. They can lead to skin burn. They can cause the damage of the cells, eye problems. And if you continue exposing your body to these electromagnetic waves, it can even graduate and cause what we call the cancer. It can also lead to the leukemia, and it can also lead to hereditary defects in children. So when you have long exposure to these rays, it can also lead, can also cause, can later cause the skin cancer. It can lead to cancer. It can also lead to leukemia, which is the cancer now of the blood. Sorry. Can lead to leukemia, and it can also lead to hereditary defects in children. It can also lead to hereditary defects, that is in children. So that is when it is not controlled. They can lead to cancer, leukemia, or the hereditary defects in children. So it is always advisable that when one is operating in a place where there is the emission of these radiations, and especially the UV radiation, the X-rays and the gamma rays, then we need to take some control measures to ensure that there is no long exposure, also to ensure that some distance is given when maybe you have a radioactive substance which is emitting, for example, the X-rays, then you should ensure that there is some distance so as to ensure that you don't get into contact with those radiations. Again, we also need to have the shielding materials. There are shielding materials that are used, especially in those companies where there is maybe some emission of these electromagnetic waves, so that they can be able to absorb the radiations. So these are the dangers. We have seen that they can result into skin burn, the damage of the cells, the eye problems, and that's why most of the times when it is very hot, when the sun is very scorching, you usually find that some of the people, especially those with do not have a lot of melanin, they may have the skin burns. It is a result of what we are calling the ultraviolet radiation. And it's very dangerous. And as we have seen that when it continues later, it can lead to cancer, the leukemia, and it can also cause what we are calling the hereditary defects in young people. Now, how can we minimize these defects? So we need to know how to minimize these defects. So minimizing the defects or minimizing the dangers. Minimizing these dangers. So I've mentioned a few. I've said that one of the way in which we can minimize is to reduce the dosage. Reduce the dosage by reducing the exposure time. And that's why it is always advisable not to undergo so many X-rays within a short period of time. So you reduce the dosage by reducing the exposure time, because we have seen that they are very dangerous, and that's why when someone or a person is being treated of cancer and is going through the chemos, you know, those are radiations. Long exposure to those chemos can lead to destruction even of the skin. And that's why you find that some of the people who undergo the chemos, even they lose their hair. Some of them, their skin is burnt due to long exposure to the radiations. Then one other way of minimizing those dangers is keep a safe distance from the radiation. Keep a safe distance from the radiation. If you've ever taken a person to undergo an X-ray, most of the times you are not allowed to get in together with the person, because they try as much as possible to ensure that there is no one who can get into contact with the radiations, now the X-rays. So it is advisable that you keep a safe distance, and that's why in those rooms mostly you don't find so many people operating the machine, the X-ray machine. So keep a safe distance from the radiation so as to avoid or to minimize all those dangers. Then lastly, it's always good to use shielding materials. Use shielding materials, e.g. what we call lint. Lint is a metal of high density, and it is able to absorb those radiations. So the radiations cannot penetrate lint because it is a metal of high density. And therefore, in maybe the industries where there is some emission of these radiations, they can use what we are calling lint or any other shielding material so as to ensure that the radiations do not get to the people, but instead they are absorbed by those shielding materials. So those are ways in which we can minimize on the exposure, or we can minimize on those dangers of the electromagnetic waves. So because we have seen that despite the fact that they have so many uses, so many of them, we apply them in our day-to-day lives. But again, when they are not used in a controlled amount, they can lead to various dangers, and therefore it's always good to control them. And again, I remember during our previous lesson we said one of the electromagnetic waves, that is the microwaves, when it is also not in controlled amount, it can also lead to damage of the skin. And that's why when you are operating a microwave oven or even a microwave, when you are heating your food, when you are cooking, ensure that you give some distance. And this is what we are saying here, keep a safe distance from the radiation. So that is the topic, electromagnetic spectrum. In this topic, we have been able to know what we mean by an electromagnetic spectrum. You can now be able to define an electromagnetic spectrum. You can be able to state the electromagnetic waves. Again, you can be in a position to give the properties of those electromagnetic waves. You are in a position also to calculate energy, to apply the wave equation, and also you can be in a position to state how these electromagnetic waves are produced, how they are detected, and also how they are used. And again, we have seen that we also have dangers of those electromagnetic waves. You should be in a position to state them and also explain ways of minimizing the dangers that are caused by the long or uncontrolled amounts of the electromagnetic waves. So that is the topic. I'd like to give you some questions. Questions from the topic. So here is the exercise. This is a very examinable topic, very examinable. So number 1A. State two uses of X-rays. And number B of that, distinguish between X-rays and gamma rays. Distinguish between X-rays and gamma rays. And number C, why are gamma rays more dangerous than X-rays? Why are gamma rays more dangerous than the X-rays? Question number 2. Which part of the electromagnetic spectrum plays a major role in the greenhouse phenomenon? So which part of the electromagnetic spectrum plays a major role in the greenhouse phenomenon? And finally, question 3, explain why a blackened bulb can be used to detect the infrared radiation. Remember, we said that the infrared radiation can be detected using a thermometer with a blackened bulb. And maybe finally, number 4, give 3 properties of the EM waves. So practice those questions and also more on the numerical calculations, because this topic is also very key in other topics, that is on cathode rays and the cathode ray tube, but also in X-rays, because we are going to discuss more that is on the X-rays as a part of the electromagnetic spectrum. So until we meet during our next lesson, whereby we'll now be introducing the cathode rays and the cathode ray tube. Thank you.